Hello students, welcome back to my channel. So we are learning the chapter 8, which is function overloading and member functions. In the previous two sessions about this chapter, we have seen what is the need for function overloading, definitions and declaration of function overloading, how do we call an overloaded functions, and what are the restrictions. So we have learned all this in detail with an example. In today's session and in upcoming sessions, we are going to learn other types of member functions, which are inline functions and friend function. So in today's session exclusive, we are going to learn all about inline function. So what is this inline function? So an inline function is a function call that is replaced by the actual program code. Okay, so this is a kind of a function where when it is called, instead of passing the control into the called place, we are going to replace it with the entire actual program. Before getting into the theoretical part of it, let us go ahead and see one example so that it becomes clear to us. So this is a normal program. Okay, we have a hash include, and this is our member function. Okay, so now look at here. Usually we have seen the way, this is the way we declare a function. We will have a return type and then name of the function and then the parameters. But you can see there is something different here. There is a keyword called as a inline. Now this is where it makes all the difference. Whenever we are using a inline keyword, now this function becomes an inline function. Now compiler recognizes this as an inline function. So what happens here? So this is the code for this particular um, function, that is we are going to return a into a, whatever parameter we are passing. Now what is happening in the main, I'm calling this function which is square in this place. Okay, so as soon as I call this function, usually if at all the inline was not mentioned, what would have happened is the control would have passed over here, and then the execution would have happened and the value would have got returned to x, value would have got stored in x. But in our case, that is, since this is an inline function, what is going to happen is whenever a function call is encountered, this entire body of the code is going to get copied over here. So this in turn will look like x is equals to return a into a, that is the body of the function. So whatever the code is available, as of now we have only one line, that line is going to get returned here, and directly here itself the value is going to get stored wherever it need to be. I hope this is clear, the difference between the normal function and the inline function. So that is what we are talking in the theoretical part. So let's move back to the theory. Now let us move back to the theory part, and I hope that now we will be able to understand every point better. Okay, so what is the definition of inline function? An inline function is a function where the call is replaced by the actual program. Okay, so it is nothing but a normal function call where we are going to replace the call with the actual program code itself. So that is what we saw. Instead of passing the counter or the control of the compiler to the code and function and then back to the main program, what we are going to do, we are going to replace the call by the program code, right? So next, the keyword inline is used to define the inline function, and functions definition start with the keyword inline. So whenever we are coming across the word the keyword inline, okay, whenever we are coming across a keyword inline in any function definition, we should understand that it is an inline function. So the function definition of that particular function always starts with the keyword inline. Next, the inline function should be defined before all functions that call it. Now, what is the meaning of this? It means that if at all you are using an inline function, then the definition, for example, suppose if I'm using an inline function inline sum, and it is over here, and my main is above that. Okay, before this I am writing the main, and in the main I am calling the function called as a is equals to sum. In this case, what is happening? after this step is going to come. Now this is not valid according to the rules or the features of inline function. So what is it saying? The inline function should be defined, so this should be above this or before the main function. It cannot be after this. So the definition has to be before we call it. So whenever you're calling an inline function, you should make sure that the definition or the code of that particular program has to be written before it. So this is what this particular point is telling us. The compiler replaces the function call statement with the function code itself. This process is called as expansion. So what is, whenever you get a question saying what is expansion, you should understand that expansion is nothing but when the call statement is replaced with the function code itself. Okay, that is called as expansion, and then compiles the entire code. So what does the compiler does here? Usually when we have a function, suppose this is my function and this is my main program here, and I am calling that particular function here, function f. So what is going to happen? The command is going to come over here, or the control is going to come over here and execute, and then again the command is control is going to come back over here. But here what we are doing, instead of moving here back and forth, we are copying this entire code itself over here, right? So this is called as expansion, and then once it is copies it over here, and then it compiles the entire code. So that is what this point means. They run little faster than normal function as function calling overheads are saved. So here what they are saying is, like I said before, instead of moving here and there, instead of the control moving backward and forward, like I said, when there is my main, first it has to go to the function, first it has to find the function and then compile the function, and then come back to the main and find out where it has to come back. Instead of doing that, what they're going to do is they are going to run little faster. Since we are copying the entire code here, what is happening is the program is running little faster, as we don't have calling overheads. That is, I have to find the function, uh, first I have to find the function call and then go to the function. Once my function is executed, again come back to the main program. These overheads are saved here because the entire code is getting copied. I hope these points are clear. So these are the features of the inline function, right? So this is the example what we saw. So if we are looking at it once again, so I have my inline function here, and then in two places I am going to call this function in the main, right? So here I am passing the value 5. So what is happening here? It is saying x is equals to square of 5 into 5. So it is going to calculate, and then 25 is going to get stored here. Similarly, I am passing 10 here. When I am passing 10, 10 into 10 is going to get stored in y. Okay, and then I am going to output it. So what is going to be the output of this program? I am going to get square of 5 is equals to 25, and also another line I am going to get square of 10 is equals to 100. This is going to be the output. Now the only difference in this program is it runs normally. Only thing is that whenever the function call comes, this you will not be able to realize it, but it happens at the compiler end, called as expansion, where the function call is going to be get replaced. I'm saying once again this, the function call is going to get replaced with your function definition. So this is happening over here as well as it is happening here. So whenever you're calling, the entire code is getting copied to the function call, and then here only in the main itself it is going to get executed, right? So let's move on. So this is the output. Okay, now what are the advantages and disadvantages of the inline function? Okay, like we have already discussed the characteristics, let us see what is the advantages of inline function. The inline member functions are compact function calls. So when I say compact, it means that they are very small function calls. Therefore, the size of the object code is considerably reduced. So object code is nothing but the code which we get once we compile the program. Okay, since the inline member functions are small, the object code what generated is also small, right? The speed of execution of the program increases. Like we said, the since the calling overheads are getting reduced, the speed of the execution of a program also increases. The program gets executed faster. It is very efficient. Code can be generated using the inline functions. The readability of the program also increases. Why? Because we don't have to go and search. In case of a large program, you don't have to go back and find the function name, and you don't have to go back and find where exactly it is, isn't it? And what is happening, the code is getting copied in your main program or the function call itself, so the readability increases. Now there is a disadvantage, and what is that? As the body of the function is substituted in place of a function call, the size of the executable file increases and more memory is needed. Okay, there is a difference between the object code and the executable file. Understand this. Okay, the executable file is the one where the compile is going to execute it. Now what is happening here, since in every place it is going to replace. For example, see here, again I'll use the same sum program. I have a inline sum function. This is an inline program, and I have some code here, and I am writing my main function. Okay, in my normal function, if at all this was not inline function, suppose I'm calling this particular function twice, what would have happened? Compiler will come here, it will find the sum, execute it, and come back, and again it will go back here and it will execute. So the executable file is not increasing. But in case of inline function, what is happening? In case of inline function, here itself, okay, here itself I am adding those two lines. Again, once again I'm adding the these lines. Okay, these lines are nothing but the code, or the body of the function is going to get replaced in the uh, function call, isn't it? So what is happening here, the file executable file size has increased. Okay, so if at all I'm calling it 100 times or 10 times, what is happening, 10 times it is copying the same body of the function. So what is happening, executable file size is increased. Because of that, what is happening, more memory is needed. So apart from these advantage, we also have the disadvantage when it comes to inline function. I hope this part is clear to you all. Now, the inline function may not work sometimes for one of the following reasons. So every time we cannot use the inline function. It looks all nice and good, but there are certain limitations when it comes to using the inline function. So what are those? The inline function definitions is too long or too complicated. So what is this? You can use the inline function only when you have your function which is of few lines. Okay, you cannot use a function which has a recursive programs, which you have a lot of loops and if nested ifs and all those such complicated things, you cannot be used as inline function. So this is one of the restriction. The inline function is recursive. So again, like I said, if at all we have recursive functions are nothing but function calling itself. So it is like one function, same function calling itself again and again. It is once again it is a complicated function, we cannot use it as a inline function. The inline function which has looping construction, again in looping what is happening, we are repeating certain set of statements, that also cannot be used as inline function. And also the inline function that has a switch or go to. Okay, I hope you all know what is switch and go to. These are again kind of a looping or jump instructions where we are going to move from one instruction to another. So when we are using these kind of a complicated looping things, what happens is the code becomes complex, and since we are repeating them, okay, we are repeating the entire code, and if at all the function is going to get called once or twice or more than that, what is happening is again there will be lot of repetitions, which is a waste of memory and waste of our energy of the computer. So that is why we have limitations on these kind of a complicated programs. These kind of programs or codes cannot be used as a inline functions. So with this, I will end this today's session. I hope you understood what is inline function. It is a very simple topic, students. So thank you for watching. Keep learning.